Okay, so this one is going to touch on homogeneous equation. Okay, this is homogeneous equation. How does it look like? First order differential equation. Basically, you have equation look like f of xy dx g of xy dy equal to 0. This type of equation. Of course, you can rearrange them. You can rearrange the dy dx equal to something. Okay, this is this type of equation. If you write them, and what is so special about this equation is they call homogeneous. What does it mean by homogeneous? It means that if you f of xy is the function depend on x and y, right? G of xy also depend on x and y. But what happens if you change the x to tx, change the y to ty? Then you get f tx ty is eventually equal to t power n f of xy. And g, if you change the x to tx, y to ty, eventually you get g tx ty is t power n gxy. Now this n is a fixed number. Okay, both of them must agree the fixed number integer. Okay, positive integer n is a fixed number. They call it degree. Okay? They call it degree of the homogeneous differential equation. Okay, so the f of xy, g of xy, okay, with together dx dy equals 0, and then you substitute x by tx, y by ty, eventually you get t power n f of xy. Same thing for g of tx, g of ty, you get t power n g of xy. And the way to solve this differential equation, there's a trick there. The way, if you recognize that you have a homogeneous differential equation, how do you know homogeneous differential equation? What's the key to point? And if you manage to show this, you know this homogeneous differential equation. So whenever a homogeneous differential equation, there's only one method to do this. Let y equal u times x. Let y equal u times x. But u is constant, no? Let y equal u times x. Then you replace y. Okay, replace all the y. Okay, so what you do is you let y equal u times x, then replace y. Okay, that's y into equation, differential equation of u and x of u. Once you solve u, then you also solve y, right? Once you know u already, then you get y. Because y equal u times x.
Sorry, Mr. Quack.
Yes.
What's the thing in front of fxy? The t something one. T to the power. Like you see the left hand side, you know the f x, then that's an ftx. Okay, never mind. Sorry.
F of dx here.
Oh.
G of x y dy here.
So is it like t to the power of what?
Huh?
T to the power of 1.
T power n.
Oh, t power n. Okay. Thank you. Yes.
T power n. You look at notes there. T power n. This n is called the degree, okay, of homogeneous differential equation.
Yes, sir.
And the way to solve them is let y equal u times x. Okay, let y equal u times x. And then you have to replace the y by u now. So eventually your differential equation replaced by u and x now. You solve for u. Once you solve for u already, you got the u come out, then you get your y come out. Now u is not a number, no? U is not a number, okay? So this is a tricky part. U is not a number. You have to figure out what is u here. illustrate those with an example. Okay, so I will illustrate with an example, right? So let me work out the solution example 1 first. So this one, example 1, okay? So start fresh, example 1. So you have two functions. This one is together with fx here. This is called fxy. This is called gxy. How do you know this is homogeneous? So you know f of xy, f of xy is equal to x squared plus y squared. Now you change the x to tx now, and y to ty. So you get all the x changed to tx now. So tx squared plus ty squared now. Now happen that t squared common, x squared plus t squared, y squared. So the t squared take out x squared plus y squared. But x squared by y squared is your fxy, right? So it's just nice. So this is actually t squared f of xy. Condition for homogeneous equation. All you need to do is check for g also. Is it the same thing happening? So g xy happen to be x squared minus xy. So put the x to tx here, y to ty. So this one become tx square, x go to tx now, y change to ty. Square, x square, and then you go t square, xy. Put on t square, then x square minus xy. So you also have t x square minus y is g or xy, right? So the g xy here. So from here, we know this differential equation is of degree 2. Okay, so this is homogeneous ODE of degree 2. So once you identify homogeneous equation, there's a standard method to solve it, right? So there's a standard method here. There is a standard method now. Almost all of them are a method to solve them. Okay. There's a standard method to solve this. This is a beginning now. So check this homogeneous. How to check homogeneous? Basically, is I say that okay, homogeneous is a one put earlier here. Homogeneous, and this is one way. How to test homogeneous? And then the standard method, how to solve this is y equal u times x. So this is I identify the pattern. Okay, and then pattern what type of equation you can Once you satisfy that this is homogeneous, then you know a method that y equal e of answer to.
Mr. Quack, what is that? There is something method to solve. What's the something?
It's a standard method to solve.
Oh, standard method. Okay, thank you.
Okay, it's a standard method to solve. So there is fixed method to solve. I mean, people just go through the formula. Okay, you follow this method, you get eventually get answer. Okay, so I'm going to show you how to solve this type of equation now. The method is still separation of variable. Okay, the method is still separation of variable. The homogeneous differential equation. Okay, so I'm going to copy this equation again to show you how to do this. Arrange the equation nicely and get this. Okay, so this is the equation here. After you know that this is the homogeneous equation now, let's arrange them now. So you get x squared minus xy y equal to minus x squared by y squared dx. Of course, you can skip all these steps just to get this one dy dx equal to minus x squared by y squared. Usually like this, so that is clearer. And dy dx here. Okay, of course, you can skip the middle step. Like if you do this, you can skip myself. Okay, dy dx equal to this first. So the method, standard method let y equal to u times x. It's always homogeneous. So now, how do you, after this, remember u is not a constant, no? So you can differentiate both sides by respect to x first. So dy dx. Okay, left hand side you dy dx here. So how to use product rule now? Product two terms. So keep the first term, differentiate second term, plus keep the second term, differentiate first term. Dx.
Wait, Joe, what's dx? Huh?
Yes, this is what?
Oh, one.
Differentiate,
Okay, one.
yeah, differentiate x by x is 1, right?
Okay.
And x du dx. Now you have dy dx already, so put it in. So the dy dx here. And your y is ux here. The y actually the ux here. Let's see what you get now. So left hand side is u plus x du dx. Right hand side is minus x squared y squared u squared x squared, right? x squared minus x, why ux here? Then you get a lot of cancellation. Minus. So to get 1 by u squared now. X squared cancel, right? You get 1 minus u. They cancel each other. The x squared. So this is actually u plus x du dx. Okay, this one I think you can simplify a little bit. Okay, u minus 1, 1 plus u squared. We're going to put all the u together, x together now. So get x du dx. Try to put all the u together. Minus u. Let's simplify this thing. Okay, 1 plus u squared minus, what is this now? Minus u plus u squared. So this will be, do I make mistake somewhere?
Mr. Quack, your denominator from u minus 1 in the third step became 1 minus u in the
Because
fourth
there's
step.
negative there and then negative there.
The negative here, okay.
Yeah.
So
you
x squared cancel.
change to u minus 1.
Yeah. So let me see where I have one mistake here.
Okay. Never mind.
Minus u squared. So I have x u dx here. 1 minus u. This is 1 minus u, right? Plus 2u squared. Doesn't look correct to me. I think I made mistake somewhere. Check again. I made mistake. Okay. So u plus 1. Now, let's simplify further. Okay, actually do this.
No, I think you legit made a mistake. Yeah.
Okay, let's check again.
Yeah, it's like from the third statement, you write u minus 1, right? Then you change the fourth statement, right, to 1 minus u already.
Yeah, 1 plus u square over 1 minus u, right? Then I minus u,
Yeah.
right? Minus u becomes minus u plus u square, right?
I think should remain as u minus 1, right?
No,
From
because the
fourth step,
negative is
denominator.
negative become negative 1 minus u is equals to u minus 1, I think.
Yeah.
I don't know what I'm saying.
Okay. Why? It should
Hey,
be
do again. Easy.
there are
For
many ways to do this. Okay, don't worry. Okay, there are many ways to do this. So let's check my answer again because I worked out the answer before. That's why I know. Make sure
Yeah,
that okay.
I think your negative there.
1 by u square over u minus 1, correct? Okay. The way is actually I just do long division only. Okay. Whether
So you go to your last one.
the last one. Okay, this is the one, right? No, this one.
You see from the right hand, right, the third statement, right?
Hmm?
You remove the negative already, but then below, right, you change it back to 1 minus u.
Oh. Okay. It's a so no wonder. Okay. So this one should be u minus 1, okay? No wonder, okay, u minus 1 here. Okay, so this u minus 1 here, so this one changed already, huh? So u minus 1 again. So you become minus u square plus u. So become 1 plus u now. Okay, u minus 1. I want to put them all together now to separate them. All right, so far, all right. It's correct already. So put all the u together. Okay, so I have x du dx. Okay, x du dx become u minus 1 plus 1 plus u minus 1, okay? So I'll put all u together, u minus 1, u plus 1, du equal 1 over x dx. Okay, so you can either do the long division or u minus 1 over u plus 1. Write them. Okay, u plus 1 minus 2, right? So it's the 1 plus minus 2 over u plus 1. Okay. You can also use the u minus 1, u plus 1 is actually u plus 1 minus 2, 1 minus 2, u plus 1. Okay. Then integrate both sides. Integrate 1, you get u. Then is the minus 2 ln u plus 1 1 over ln x here as a constant. Okay, then you change the u back. What is u here? Y equal to u times x. So u is actually equal to y over x. So we can get y over x here minus 2 ln of y over x plus 1 equal to ln x plus c. Okay, so this becomes the solution of the first example. Okay, long division or just a bit of tricky not balancing. There are many ways to do this. Y equal to u times x. So we change back to u here.
Mr. Quek, can I ask a question?
Yep.
Why do we want to make the equation more complicated?
What do you mean by more complicated?
Like now got initially just like y and x, but then ended up with like y over x and ln also.
This is otherwise how to solve it. Again, I'm not sure how to solve it. Initially, the equation is not easy, you know. We try to solve it. Okay, look at this equation first. Okay, this equation. Look like this equation. How do you solve it? There's no way to separate x and y now. If you just look at this equation, how do you separate so that x on one side, y on one side?
Oh, okay.
That's why there's a fixed method. So this is a tricky question. This question, how do you separate them? So the x on one side, y on one side, you cannot do this. You try to do all kinds of method, it doesn't work.
I see. Okay.
Okay, so if this situation is okay, fine. You just check whether it's homogeneous or not. Okay, homogeneous check. Let's start our question. Homogeneous or not? Homogeneous, then there's a fixed method to do this. Just let y equal u times x. Everything will settle. If you do it correctly, everything will settle. So this is example 1. So example 1, eventually got this. Right. Example 1. I can stop recording for example 1. So stop recording for example 1 first, so that it will be smaller chunk of recording.